Welcome to this week's episode of the Structural Engineering Podcast. My name is Max.
I'm Zach.
And this week we sit down with Ryan Smith, the director over at Sideplate. If you don't know that much about Sideplate yet, I would check out our previous episode. We talked to him. He's one of the first companies I think we talked to. It had to be about 6 months ago. Yeah, we had a great intro to the whole Sideplate system, which is a really cool solution to moment frames. They're stiffer than your typical moment frame, and they put the yielding directly into the beam. So for a lot of reasons, they're worth knowing about. They had a big reveal, basically, scheduled for the NASCC, the Steel Conference. And as many of you know, the Steel Conference was canceled. Bad news for a lot of people that wanted to present, but good news for people that couldn't pay to be there, and we got to watch a lot of cool sessions.
I wouldn't say it was canceled, it just went virtual.
Well, good point.
Oh, good point. Yeah, I think this week's episode with Ryan is going to be pretty cool. I definitely learned some new things, and what I really like about interviewing Ryan is he always has an answer.
Yeah.
Like we tried in the last time to ask him some hard questions, this time as well. And that guy's always got the answers, Max.
I know.
We need to start quizzing him on brace frames or something, that he doesn't know. But anyways, yeah, I think you guys will really like this episode.
If you haven't seen this new connection, on April 22nd, Sideplate debuted this fully bolted moment frame connection. Right now it is a more for the East Coast market, an OMF system, but fully bolted is kind of a game changer. No welding, obviously. But you could take a look at this. We'll send a link. We'll put a link down below to some photos and some of the links to their website for some additional information. So Ryan, we've had you on the show before, and we learned all about the Sideplate system. And it sounds like you've got a new system coming out. And although we've been introduced, can you give us a quick introduction again for people that didn't listen to that first episode? Who are you?
Absolutely. Thank you so much for having me back on. The podcast that I did with you was the first one I actually have done.
Nice.
I had such a good time. I've actually done at least another couple after that with other groups, and just really love what's happening here with podcast and the engineering community and what you guys are doing. So definitely excited when you guys saw the our new connection that's coming out and invited me back on. So thanks again. For those of you that didn't hear the last one, I'm Ryan Smith. I'm the director of Sideplate Systems, responsible for managing our extremely talented team of structural engineers, researchers, software developers to really bring the highest quality moment frame connections to the design and construction community.
And so recently, we got you on because you recently debuted a new system. Can you give us a real quick, what is special about this system? What is this new system?
Yeah, absolutely. We're so excited. So innovation is built into Sideplate's blood all the way back from 1995 when we started solving an issue at Northridge. And Sideplate connection moment frame technology, right? So we're talking about pre-qualified connections for high seismic and moderate seismic areas for steel buildings. We're also talking about moment connections for wind-governed projects and low seismic areas as well. And so it's a patented system. It's been developed with full-scale testing. And it's really evolved from 1995. And this latest debut that we did in April was of our new all-bolted connection. We basically had connections that started out as being welded that included CJP or full joint penetration welds, very expensive and time-consuming welds, to all the way to 2016 when we released a field-bolted option that just has fillet welds in the shop and bolts in the field. And then our latest achievement here that we'll be talking mostly about today, I believe, is the all bolted, which means there is no welding on our connection. So that's kind of the new excitement, the new available item that engineers and contractors can use in their buildings.
Yeah, that's pretty huge, and there's a lot of perks to that, which I think we'll get into later. But I wanted to ask first. You mentioned in your launch video that you went from concept to reality in this in a year. That sounds crazy fast. How did you get this going in just 1 year?
Yeah, and I think even a year is probably conservative. I think it was actually even faster than that. I said a year on the video, mainly being is that there was some preliminary work done, but the bulk of the work was probably done within an 8-month period. So it was pretty extraordinary.
Yeah.
I will tell you that we've done this quite a bit now, right? So we've been innovating since 1995 with various new developments and continuous improvement items all the way up until now. So I think one of the good thing is that we had history behind us, right? So we knew and experienced We've also had the people that are at Sideplate have been there a while now. And so we were a really young company. Even back 10 years ago, we didn't have a lot of highly tenured people. Nowadays, the people there have been there a while. And so we're able to gain that experience of what to expect. So that certainly helped us. The other big thing we were able to do is our industry partnerships with those that build our connection. Again, for those that don't know enough about Sideplate from this perspective, we don't actually manufacture or fabricate anything. We just do the design work. The actual people, the fabricators and erectors, are the real heroes here that actually erect and build our stuff. We've built such great partnerships with them and able to have really good dialogue that the early stages of the development of the connection was much quicker than usual, because people now are understanding what we're going to do and are willing to give us the time that we need to innovate. And so several different construction partners, it'd be too many to name on this call, have been supportive of that. So that was a big idea of it. We were able to go faster in the beginning. And then our researchers, and we know how important this was for industry. And so when I told our team, is like, no, it's not going to be our typical process where we take a year and a half to 2 years. I really need to get this in the hands of our clients within a year period of time. The looks, I will tell you, was a little bit in shock, like he's got to be kidding, right? But I will tell you, they all stepped up to the challenge. They moved things around that wasn't customer focused. We want to always continue to serve our customers, but we were able to just dive in. And then, of course, when I made that, I didn't know we were going to be fighting a historic health pandemic during the middle of it. So I will tell you that I think my team might have thought that this could be some leeway that I was going to give them when the whole world shut down. And they were unpleasantly surprised when I said, no, it's now more important than ever for us to innovate. And so they were able to push through it, though. They're a fantastic team.
Wow, that's awesome. That's crazy, 8 months. So when starting with a new product, how much time do you spend on the analytical modeling versus the field testing?
Yeah, great question. I'm glad that you asked it, because this is a differentiator with Sideplate compared to other innovative companies, right? We have invested heavily in the analytical side of our business. We have high-end finite element softwares, PhDs in our office that are actually able to run some of this analytical work. By being able to do that, you can solve a lot of errors or constructability issues, stress concentrations, things like that early on. Now, I will tell you that to do this, these models that we're running basically analytical test programs on can take days to run. So we've been able to invest in the infrastructure just to do our virtual testing. So we even call it a virtual lab that goes on in the beginning. And we run these things overnight sometimes to have them come in. We get the results in the morning. We spend substantial amounts of work up front running analysis on the computer. However, at the same time that we're running those analysis from an engineering standpoint, that is just one part of the equation. And I'll be honest, it's probably not the most important in my mind. We need to actually make sure this thing works and is safe and has the same high quality standards. That's a given. It's going to have that. But the variables we're really looking at finding out is constructability and the needs of our clients that are out there. So at the same time that our researchers doing the analytical work, I had construction managers, I had our director of technology development was out meeting with clients virtually near the end. Our director of construction services and our regional engineers were out there talking with our clients with non-disclosure agreements and saying, hey, these are the options that we have. We spend considerable time during that. And then we start to slowly narrow the product offering down to the final ones that I actually debuted by video on the 22nd. I'll tell you, by the time we get into fabrication, we're pretty much done. We don't expect that there's going to be any big changes for the debut, although we do know that shortly after that, we're going to make some changes in regards to the final release. That's one of the reasons we do this stage of debuting it, because the concept is there, but the final release is going to actually happen in July. The reason being is that we learned some stuff during that fabrication process that will just make the product better. We could release it right now if we wanted to, but it won't be quite as good as it will be in July. And we want to make sure we do the right thing for our clients. So substantial work up front. Really, at the debut point, there's not much in the fabrication side.
Okay. So coming out early July, where do you see this connection being used the most? Like, where is the target building type or target client?
Yep. So this is right in line with our strategy. Some people know Sideplate as a high seismic connection, and we appreciate that. It was developed out of the Northridge earthquake. We're based out in California, obviously a high seismic area for probably most of your listeners know about. But since then, we've had substantial growth in the eastern part of the country. And why we do pride ourselves on the high seismic work that we do in lab testing and that, we've been asked considerable number of times from our fabricators and erectors and general contractors in the East that we want something that's geared specifically towards us. We met some of that challenge in 2013 when we debuted the field bolted connection for low seismic to moderate seismic areas, wind governed projects, and they really loved it. Bolting in the field is something that can be done by many different types of individuals. It doesn't have the same type of inspections that you need when you're talking about welding out there. Labor has been an issue in some areas, particularly with other industrial work and stuff, taking some of these qualified welders into that area. And they really liked it. The issue that we ran into, though, is that because they like the field bolted side of it so much, they said, you know what? We think we want to use this innovative equipment a lot more. The equipment industry within the fabrication world has substantially grown, as well as the bolting world. The innovative bolts with strengths and abilities to tighten and torque and things of that nature has grown. And we wanted to take advantage of that. So did our clients. And focus on that Eastern market. So what we did is created the all bolted. So mainly fabricators that have this sophisticated and also normal procedures of bolting, they don't do a lot of welding, for instance, can use this. So where is it going to be used the most? It's going to be likely used more in low seismic to no seismic to wind governed project. It currently isn't going to be used in the high seismic market. That's not what this is geared towards right now. Maybe in the future it will be. That's also part of one of the reasons we could get to market so fast, is it doesn't require full-scale testing at the moment. Although our analytical testing has been proven to be just as good as the full-scale testing, it's able to fast-track it through. And so that's one of the things we're going to be using it there. And we're going to be using it for any fabricator that wants to be able to specialize the connections to their shop. They no longer are forcing the side plate connections to go through the welding lines or welding stations. Now they can use that equipment. So it opens up the market considerably for many different more building types now, building sizes, because now you don't need a big giant job to use side plate with certain fabricators that have that type of equipment. But those that do can certainly use it. It's just bolt holes now, which is a big thing. So all the markets in the eastern part of the country is really where we're looking.
I feel like that leads to, will it go towards an IMF system or an SMF system, a seismic? If that's something that is maybe development you don't talk about, it can be, you don't have to say anything. I have to ask.
Absolutely. And the question is, it's not the first time I've heard it, by the way, if you can be surprised by that. I can tell you what history has shown. In 2013, we debuted a field bolted connection in the eastern part of the country. In 2016, that same connection became a special moment frame connection. And the reason being is that it was very successful. I will tell you that since we debuted the connection in April, I've had quite a few of engineering clients and fabricators in the western part of the country wonder when it's going to be available for them. Again, our desire is to give the most innovative connections to anyone that feels that it's the appropriate choice. If the western part of the country feels that they need to be able to use this over there, SidePlate will deliver on that innovation. Sure.
Awesome. You touched this a little bit, but I think maybe we could go a little more in depth. But why would you want a bolted connection option over a welded connection?
Yeah. So, and you don't always, depending on the type of connections that you're using, perhaps welding is the only way to go. I will tell you why bolting typically is sometimes chosen over welding. And it has to do a lot with labor is one of them. Sometimes you don't have the availability of skilled laborers that can do the welding. Inspections become a lot more invasive with welding, particularly on high-end welds. And some of the welds that we have in our connections on our welded connection require that ultrasonic testing and things like that some welded connections have. Ours don't, because we don't have any CJP welds, but some do. Also, there are weather issues and stuff in the field that can happen with preheating and stuff like that. You need to make sure your weld metal can sit correctly. So weather conditions can usually be a drawback from that. The big deal for bolted connections for side plates specifically is the fact that bolting allows more flexibility and tolerance. Side plate is built in a system that has been well thought out with various geometric compatibilities, right? So we have beams that come between plates. We have certain angles and dimensions that we need to keep. And we have certain, if you're using a welded connection, you need to have pieces of metal very close to each other with little gaps to be able to weld. The nice thing about bolting is that can take out that slack. So one of the things that people always wonder about with side plate is, what about tolerance? Steel's never straight. Steel's never perfect. How do we deal with that? And side plate, since 1995, has come up with really good solutions and to be able to do that working directly with our partners. But in the end, you still need to make sure on welded connections that the steel is right next to the steel to be able to weld it. Now with our bolted connection, the availability of tolerance in the field, mistakes to be made with anchor bolt locations and that can be taken out considerably. So now our people are able to actually have little to no issues in the field in terms of tolerances simply because the bolting is much more forgiving. At the same time, I touched on this earlier, is that the machinery and bolts that are being used by fabricators across this country and the world are becoming much more sophisticated. They're now able to run these machines and let the skilled work, but done by the human eye, be in other areas that don't need to mark out where holes are located, right? We have machines that can now do that. Fit up and stuff becomes much easier. The watching the all bolted connection get put together in our mock-up was just astounding to me how easy it was.
So you mentioned being very skilled. I've heard anecdotally that skilled tradesmen are harder and harder to find, especially welders, right? And this connection helps kind of relieve that issue. Have you seen data to back up the shortage of structural welders? Is this just something that structural engineers talk about in the office that is partial truth?
Right. It usually comes down. So I've been on the engineering. I'm a licensed structural engineer by trade, right? So I've gotten those RFIs that says, hey, we just can't get this done. It looks like the schedule's going to have to push. So yes, you have to balance some of that. But I will tell you that it is real in that skilled welders are an important trade and well sought after. In fact, there's certain building types. Industrial market is one that has used considerable amounts of welding in many of their different systems. And as we become a more global economy, we've seen quite a bit when talking to our clients that they do realize that they can find more people that can bolt than they can about qualified welders. And part of the reason, so it's real. So I will tell you that it is real, and it's gotten more stringent or more impacted in the last 7 years I've been at Sideplate. So that's happening. I think it has to do with the type of work that's being done, but also it's that you're starting to see more sophisticated connections and things that are coming out that use a lot of welding. And so people are needing more welders on some of the stuff. That's why we wanted to buck that trend a little bit and head toward a route that in the shop, you don't necessarily need those welders. You can use those welders for other type of projects like plate girders and things like that we're talking about, longer spans and stuff of that nature, and leave the moment connections to be able to be done on those machines with qualified fitters. And so we've done that. We saw this work really well with the field side of the equation, which was the first problem we tackled, and now we've moved it to the shop side as well.
Nice. Wow. That makes sense. I've tried welding. I'm not very good at it, but I can bolt. I went to Cal Poly San Luis Obispo for my undergrad in the RE department, and we had a welding lab there. And I will caution anyone that make sure you don't drop the gun down on the table and have the trigger pushed without your mask on. It literally looked like I was running around with a chicken with my head cut off, not being able to look at it right because then I'd blind myself. But who knows, I'm probably burning down the lab. Everyone was okay. There was no one injured in this incident, but I did realize I should stick to pen and paper. Yeah.
Oh, yeah. Yeah, Max and I talk about this all the time. Welding, wood framing. Yeah, we should just stick to pen and paper and let the professionals do their jobs.
Hey, Zach welded my camper together. It's still rolling, so you can.
I hope the DOT is not listening to that.
Yeah, so. Really. All right.
So do the bolted connections provide the same stiffness and strength as the same size welded connections? And with that as well, are there tighter limitations to what kind of beams and column systems can be used?
So this is a common question that we get to. I will tell you, there's nothing at Sideplate that we want to do to take away from the standard that we've set with our original connection from a performance standpoint all the way back to 1995. Interesting enough, in 1995, I talked about a lot of evolutions of Sideplate. None of it has necessarily been, we've always had a similar or maybe even slightly better now performance, but really it's been focused on the economy side of the connection as we've evolved. We had a great system out of the box from a performance standpoint and haven't needed to modify that much in the future other to make it more economical. And so we wouldn't want to come out with something that was an inferior product. That's just not in our DNA. So that's one of the reasons that some of the previous evolutions have taken longer than 8 months to do. Given our skill set and the field bolts, we were able to make this much faster. And I'm happy to report that the stiffness and strength of the connection are identical between the bolted and the welded connection. Now, I will preface that with being when you start to put more holes in things, which you have to do when you're talking about a shop bolted connection, there are more checks that have to be done internally by our engineering team and the softwares that we've created to do so, right? We have net section checks and block shear checks and things like that are required. And some of those checks can require things to become slightly larger in terms of thicknesses. And so you will see a slightly thicker side plate, for instance, on some of our bolted connections than you might on our welded connection. However, it's very minimal. We're talking about 1/16 of an inch, things like that. And we do other things to make the connection just as economical from a material standpoint. Obviously, you're getting substantial benefits from a constructability standpoint, but we're always cognizant of that as well. The second part of your connection, of your question regarding the connection is geometric compatibility related, right? This is what I talked about earlier in regards to, this is something that people ask about with side plate. Because we do typically, or still, we have to fit a beam between two side plates on the column. This is one of the most exciting things about the shop bolted connection is that the dimension that's typically held and causes us to be cognizant of this geometric compatibility is the space between the side plates. Okay, so I encourage anyone to go online at sideplate.com and look at our connection if you haven't seen it, but the side plates are typically welded directly to the column flanges, right? So that means the distance between the side plates is set by the column flange, okay? Because it has to be welded to those, which means we need to make sure that the beam flange, for instance, that goes between that has to be smaller than the column flange. Here's the exciting part about all bolted is that we now control that dimension because we actually put two angles onto the flanges of the column, and we can make those angles anything we want, which now spread the plates to whatever dimension we want. So interesting enough now is that geometric compatibility is much more relaxed with all bolted. Again, remember I talked about bolts take out slop or allow for more tolerances. The way we've designed the connection also does that. So it is now much more forgiving in terms of the beam and column combinations you can use. Now, I would be remiss though if I said that was a big problem with side plate for our welded connection. That too, it's not. We're only talking about this benefiting certain circumstances where there's a limit in terms of beam depth or things like that go into it. But it is nice to have that flexibility and freedom. But geometric compatibility is typically not a problem with side plate, even less so now with the all bolted.
Yeah, so if there's not really any negatives here, could you see a situation where most of your connections move towards bolted?
Yes, and that answer is yes for all of our connections. We've started to see that. I will tell you that when we released the first field bolted connection in 2013, we weren't quite sure about that. We were assuming we were going to use a welded option and a bolted option, provide that option to our clients, and some were going to choose it, the bolted, and some were going to choose the welded. The reason we thought that is because we didn't know if there was a threshold for when the number of bolts in a connection outweigh putting down a line of weld. And obviously, if you get to really, really big sizes, you may have a lot of bolts for our standard. I then realized quickly, given my background has really been based on the western part of the country where welding is very, very prevalent. On the eastern parts of the country, and by east, I just mean really east of the Rockies, so not that far over, bolting is very, very common. And I saw connections out there, not ours, but that would have 70 plus bolts in some of these connections. And I'm just like, whoa, that's a lot of bolts to put there. Why wouldn't you guys want to weld? And I asked this to some of our clients, and they really said that the amount of energy and effort that goes into welding from firewatch and things of that nature can be very problematic, and they'd rather stuff 70 bolts than do it. When we released the 2016 connection for high seismic, which typically does use bigger member sizes, it was very apparent to us that this was a change in the market, that people were wanting us to do it. In fact, we missed the mark a little bit on the limitations of sizes we went up to, and we didn't test big enough stuff because we didn't realize that people would want to stuff so many bolts more than welding. And so we had to go back into the lab in 2016 and actually test beams up to 400 pounds a linear foot plus. So I do see that the market is moving in this direction. Now, I will tell you on the all bolted side, There are particular fabricators out there that do have substantial setups for welding. And so it's still yet to be determined if some of those shops would prefer to use a shop welded option. Pretty much everyone's gone to field bolted. That's not something that I think people are moving away from. Everything will go field bolted with side plate in the future. But it's still yet to be determined whether some fabricators will prefer the welded or not. It's still too early to say. My guess is that watching that thing go together on that mock-up and some of the early feedback that we've got, you're probably to see a shift in the side plate connections to all bolted. But we're going to let the experts determine that for us.
Yeah, I like it. Max and I do a lot of steel buildings, and we found that, the misalignment of bolt holes is fairly uncommon, but, tends to happen every once in a while. How's your connection address these issues?
Yeah, so the more bolt holes you have, right, the more chance that you have for misalignment. And one of the interesting things, though, is that on our connections, we utilize the largest holes that we can in the code. So our holes are actually an 1/8 inch larger than the bolt diameter they're doing, because we're using typically 1 inch and larger bolts in our connections. And we do that specifically for a reason. One, we can use less bolts. The equipment to be able to tighten 1 inch and 1/8 inch bolts is very prevalent. And then we can also use a larger hole to stop those issues from happening. However, if they do happen, particularly in the field, what we've done is use standard bolt repair hole methods that are done, plug and fill type procedures, very common in the industry. The good news about shop bolting is that the beam and columns are still in the shop. And so we've actually seen and actually ran some test protocols on and understanding analytically what happens if they just missed an alignment, right? So that the equipment somehow got programmed incorrectly, again, very, very rare. But they missed it all by 3 inches, for instance, and the bolt line was 3 inches off. It's tough to do anything once the thing's in the field and you're trying to stick the beam in and fit it up. But in the shop, you just run that thing through the line again and remake the holes in the other spots, right? And so those are things that will be available to our clients. And we'll always support the engineers that are doing it in order to make those fixes, right? We're a full service engineering type center for our clients, right? We don't do the engineer record work, but we do focus on supporting those engineer records and our fabricators and erectors on fixing those problems as quick as possible. Limits cost overruns and things like that on the job. I will mention one thing too on bolt alignment. We were interested in our mock-up, right, because it's not a real job, to see what could we get out there in real life. And so we actually had the fabricator choose the worst possible beam they could from a tolerance standpoint that was just under the allowable AISC standards. In fact, I talked to the shop foreman. He said if they even got this, they would actually reject this material, because there would be, even though it's within tolerances barely, there's probably something that's going to go wrong. And so we said, no, put that beam in. And everything fit up just fine. And the reason being is that we're able to have so much tolerances in regards to our connection with the 1/8 inch oversized holes that we have, and the way we've designed it to allow the slot to fall out of the bottom of the connection. Basically, where we put the holes appropriately allows that to happen. And they were just astounded. Again, just to tell you, this particular fabricator said that they would be able to basically eliminate the need for layout with our connection in their shop, simply because of the tolerances that are allowed. So they didn't have to be as stringent on those. And it's just real exciting to see that what the excitement level is from customers that have been doing side plate for so long. Here we are in our 25th year anniversary, 1995 to now, and just to see that people are still getting excited about what we do in the steel industry, and it's just fun to witness.
That's fantastic. All right, so the last one I have for you here. The message that you sent out earlier, SidePlate, this new connection is going to be officially available this summer. What can clients expect to have available at that time? What expectations do you have when it is officially released?
As I came from the business development type world, yes, I'm a structural engineer by nature, but I've always loved customer service and building a relationship with clients. There's nothing more frustrating for me, and my team knows it, for when someone sees my video of debuting it, and I can tell you our phone started to ring right away from clients saying, hey, we've got a side plate project right now. Send us your new details that show the all bolted connections, right? Which is, I love hearing, because that means we're doing what our clients need. So what are they going to get in July 1, probably is where we're targeting, is really the ability to start designing with our connection. We're going to be working to make sure that we can efficiently in-house have all the softwares that we need to be able to efficiently meet the very stringent and quick turnarounds that we have given our clients historically. So our clients are not going to have to worry about the concept of saying, oh, it's something new. Is this going to be now instead of a 48-hour turnaround or a 1-week turnaround, we should expect a month turnaround. I want to make sure that we don't change that expectation. So we're working very diligently with our software team and our researchers and some of the feedback we've gotten from the mock-up to put together our design softwares in place to be able to have that type of turnaround. So our clients can expect that for low to moderate seismic projects that are mainly wind governed, eastern part of the countries can be able to utilize this in design starting in July 1, and that they're going to have similar type turnaround times and design qualities, drawings, et cetera, to be able to do it. What our clients won't be able to have at that time, but we'll be in the process of developing further, are some of the detailing tools and estimating tools that we have for some of our other connections. However, we have made great steps in our estimating. We should be able to give some preliminary estimates on takeoffs and things like that with it. It just won't be the full-blown package they're used to seeing for other connections. Those will come shortly behind it. But in talking with our clients, we've asked questions saying, hey, do you want us to wait till we have every bell and whistle on it? And I can tell you the feedback was overwhelmingly no. We can do some of the stuff that we're used to doing anyways with all other connections that didn't invest in the kind of detailing components and things that you guys have. Give us that option and let's make it happen. And so we should expect all the bells and whistles in the future. You know, we're still debating on what that date is going to be given some of the feedback coming in, but it should be locked and loaded and ready to go July 1 for our clients to start going all bolted with Sideplate.
Gosh, that's so exciting. I'm excited to see more what happens come July. Now, with us recording this, you know, in a worldwide pandemic, Max and I are working at home. It looks like from your guys' backgrounds here, you guys are also working from home. How's that been going? What is it like having your entire team working from home?
Well, I think, so I made that difficult but fairly easy decision. Man, I don't know how long ago now it was. It feels like it was a year ago. But to have all of our employees, for their safety, work remote. And so we actually have every single employee, all 30 plus of us, working remote at home. And I will tell you, and I've mentioned this to my team, this is the most resilient team I've ever been a part of. And I've had the opportunity of leading teams and being part of many different teams in many aspects, professionally and personally, throughout my career. And this team is by far the most resilient. I didn't expect anything less of their resiliency and their ability to keep functioning. What I wasn't quite expecting was the increase in collaboration that I felt when we all separated. And I think it was, many of us took for granted the fact that you could walk by someone's desk and say hello and things like that, how much we were actually doing that in the office until you have to be more strategic about it and actually push that call from Microsoft Teams or whatever you're doing. And I've seen just an amazing amount of collaboration. I will tell you, I do get a little tired of talking to my computer screen during the day too. I think I'd be lying if I said that it's just something it's super exciting for me. It's I do like talking to people face to face. I hope we get back to that in the future. But we're the busiest we've been in the 7 to 8 years I've been at Sideplate. And our team is holding strong and steady. And we're just so thankful to all the people out there that are continuing to work and keep us safe and get us ready to get back to the office. But I couldn't be more proud of my team, proud of our clients, keeping working and keeping us going, and MyTech as a whole. So our parent company, MyTech, has been able to fully support us from an IT side, from a development side. We're still pushing through with innovation, and that's been great to have that kind of support.
That's fantastic. Yeah, it seems like on our teams at our individual firms, it actually has done a good job in promoting how we work together. The only negative is my ears kind of hurt from headphones all the time. But yeah, you just have to be more purposeful about talking to people. And it generally happens a little more than I think it did happen in the office. It's been working out. Well, thank you guys so much for joining us again. It's really cool to learn about the new connection. I'm excited to see what comes out of it this summer and see people starting to use it. So hopefully I will get the opportunity to use it myself, and appreciate you guys being here.
Looking forward to it. Yeah, and I encourage everyone, if you want to see it, we've got some pictures and renderings and stuff on our website. So sideplate.com. Please head out there. Also, you can see all the regional engineers' contact information on there. If you have specific questions from a design perspective, from a construction perspective, please go there. Shoot us an email. We're all working diligently on it, and would love your feedback on it from what you see, and just look forward to being able to show it to you in real life once it gets going later this summer.
Well, Max, that was another great episode with Ryan Smith. Sideplate is a company that innovates just over and over again. Like he talked, they started in the 90s. What's really crazy is that they were able to develop that connection in 8 months to get it to where it's at today. And I'm really excited for July's release date. Thank you guys so much for listening to this week's episode. As Ryan noted, please reach out to them with any questions. They would love to help. Max and I are also here to help with anything related to anything structural engineering. So please reach out to us on Facebook, Instagram, LinkedIn, email, pretty much any way you can think of. We're there. Until next time, see you later.
Bye-bye.